We're going to do a little review of reciprocal functions. If you have 1 over f of x, wherever your original graph's x-intercepts are, they are non-permissible values in 1 over. Because if you do 1 over that, then you get 1 over 0, and that's not allowed. Okay? Today, we're thinking about all the situations where f of x is a parabola. So, in the getting started part, you saw that sometimes you could have a parabola with 2 x-intercepts. And that could either be a parabola opening up like that, could have 2 x-intercepts. Can you see that you could also have a parabola opening down with 2 x-intercepts? What would it look like if you only had 1 x-intercept? Does it make sense that your parabola would have to have its vertex on the x-axis to only have 1 x-intercept, and then you would have only 1 non-permissible value. And it could either be opening up, is that big enough, or opening down. And then is it possible to draw a parabola with no x-intercepts? Yes. You could either have one opening up that never touches the x-axis, or one opening down that never touches the x-axis. And each of these situations is going to create sort of a similar type of reciprocal graph. And that's what's on the top of. They break it up into 3 shapes. This one has no x-intercepts. This one has 1 x-intercept. If you have a red pen, you can add it in. And this one has 2 x-intercepts. And they all have a horizontal asymptote at y equals 0. Because every single parabola, if we go back to our parabolas, we remember that we had a y-intercept, a horizontal asymptote at y equals 0, whenever the original graph either went up forever to get really huge y values, or down forever to get really huge negative y values. Can you see no matter which parabola you draw, it either goes up forever or down forever. So we will always have that asymptote at y equals 0. Because when y values are huge, and you do 1 over a huge number, it gets closer and closer to 0. Okay? Now, I like to give each of these a name. So, are you ready for the names of all 6 of these graphs? This one. Well, you can, if you can give a better name than, like, over the years I've developed names of these that I've come to really appreciate, but you can come up with a better name. Okay? Oh, by the way, this one, I think, is the official graph of Winnipeg. This one in the bottom left-hand corner. So see if you can figure out the name I'm going to come up with for that one. Okay? What would you like to call the first graph, top left corner? Any names you like? Feel free, you know. You just like, if it calls out to you that looks like Fred, whatever, it's good. What does it look like to you? Luke, you got one? Yeah? No, I thought you said it looks like
Stonehouse. I think Adam was, I'll say it, John Ford.
Okay.
You guys are weird, bro.
I call this one speed bump.
Oh.
You see it, little?
Oh, the bump was Paul.
And then the official graph of Winnipeg? Figured pothole.
Oh.
Right. That's why I call that one the plot hole. Okay. Next one.
Mountain.
Close. You're very close. Because I actually think of the asymptote as like volcano.
Oh,
Yes. The volcano graph.
Like sinkhole or something.
Valley.
Sinkhole or trench. What?
Trench.
I like to go with trench.
Oh, it's a bridge.
Oh, bridge is not bad.
What's on it? It's not like golden.
I like that. But then how can you tell the difference between this one and this one? Are they both bridges or?
Oh yeah. Oh, the bottom one would be like crown.
Okay.
Oh,
That's what I call it. Yes, that's what I like. I call that one Batman. You see Batman?
Oh, it's like. I see it.
I don't know if it's a clown. Could just be sad face. Do you see the sad face?
Even like 2 eyes. It's a sad smile.
Kind of looks like a sad octopus or something. Because I've seen so many sad octopuses in my life, you know, that definitely is what resonates for me. Okay, so these are the 6 different things that can happen when we put a parabola on the bottom. Sometimes we'll get a speed bump, sometimes a pothole, sometimes a volcano, sometimes Batman, and sometimes a trench. So here's our first graph. Again, same strategy as before, we're going to draw 2 graphs. One where I'm going to graph the bottom part in blue first, and make sure that I label my x-intercepts and as many nice points as I can. And then in green, over here, I'm going to graph the reciprocal and go through the steps of graphing a reciprocal. So in blue, is this in vertex form? It is. What is the vertex? This, just a reminder, as we get ready for exam, what is vertex form? It's like this, right? Where P and Q are your vertex. Can you see the Q is -1? And with it's squared, but there's no number for P, so P would be 0. So 0 and -1 is our vertex. Which way does this parabola open? Up or down?
Down.
It opens down, so I go over 1, down 1. Over 1, down 3. And I can label these points. I've got 0, -1, 1, -2, 2, -5, -2, -5, -1, -2. That's my points. Now when I go to reciprocal, do I have any x-intercepts? No. This one is one that would have no vertical asymptotes. Second, I will always have a horizontal asymptote when it's 1 over a parabola, because this graph goes down forever. Now we take our nice points. What's going to happen to 0, -1? It's going to become 1 over -1, which keeps it the same. What's going to happen to 1, -2? It's going to become 1, 1 over 2. What's going to happen to 2, -5? Right? Because all that happens in a reciprocal graph is you take your y value and do 1 over that y value. So same thing over here. We're going to have -1, negative 1 over negative 2, and I'm going to have negative 2, 1 over negative 5. And which graph did we get? The Winnipeg graph. The pothole graph. So circle questions 3, 6, and 11B.